Welcome to Chapter 12. In Chapter 12, we're going to talk about solutions. Very important part of chemistry that has a lot of applications in especially biology, where solutions are made, and of course chemistry, but a very realistic and practical topic. Sections 12.1 and 12.3 we're going to summarize together. We're going to skip section 12.2 for now, but we will come back to it when we do acids and bases. So right now, concepts in section 12.1 and 12.3, properties of solutions and solubility. What is a solution? A solution is a homogeneous mixture. Remember, it's the same throughout, homogeneous. It's typically a liquid. Consists of a solute, that is the component that is being dissolved, and a solvent, the component that's doing the dissolving. If we can think of many different types of solutions. You can open your refrigerator and you can find many solutions in your refrigerator. If you have apple juice, if you have soda, okay, if you have, I'll just use those two examples for now, okay, solutions, okay. Solubility is a term that describes the amount of solute that will dissolve in a solvent. And we have the terms miscible and immiscible. And the term miscible refers to when the solute and the solvent mix together. For example, if you take salt and water, the salt will dissolve in the water. If you take oil and an alcohol, the oil will dissolve in an alcohol. Immiscible, the solute and the solvent do not mix together. If you took oil and mixed it with water, they are not going to mix together. You are not going to have that solute dissolve in that solvent. What are some factors that affect solubility? First, the nature of the solute and the solvent. Are they miscible or immiscible? This also leads to the concepts of polar and nonpolar, which are discussed a little further in when we talk about bonding, and in subsequent courses when you talk about polar and nonpolar compounds. But right now, if they're miscible or immiscible, okay, that will affect if you will have the solute be soluble in the solvent, okay, just as we talked about. Temperature affects solubility. As you increase the temperature, you increase solubility. Okay, if you have 2 cups of water, and one is cold and one is hot, and you put sugar into each of those cups of water, the sugar will dissolve faster in the warmer water than it will in the colder water. Okay, the temperature, the heat energy helps for it to dissolve faster. Pressure affects solubility. Increased pressure increases solubility, and this is also called Henry's law. Think for an example of a carbonated beverage. Let's say that you have a can of soda, and the can of soda contains carbon dioxide and it's bubbled in under pressure. So you have a closed can of soda. Carbon dioxide is under pressure. When you open that can of soda, you hear the fizzing, you see the bubbling, because when you open that container, you have decreased the pressure. So therefore you decrease the solubility and the carbon dioxide bubbles out. So pressure affects solubility. Under pressure, that carbon dioxide is soluble in the solution. You don't see the bubbles when it's under pressure. Another factor that affects solubility is the type of solution. And is that solution an unsaturated solution? Is it saturated or is it supersaturated? Unsaturated, meaning it has less solute than the solvent. Saturated, the solute and the solvent are in equilibrium. And supersaturated, you have more solute than solvent. I'm going to show you a demonstration to help illustrate these terms: unsaturated, saturated, and supersaturated. To explain the terms saturated, unsaturated, and supersaturated, I have a demonstration here to show you. Okay, every substance has a saturation point. Saturation point for sodium chloride is 36 grams of sodium chloride per 100 grams of water. So I have roughly here 100 grams of water, okay? And if I started to just put a little bit of sodium chloride in it, okay, and stir that up, okay, I have just made an unsaturated solution. All of that solute is dissolved in the solvent, okay? So that's an unsaturated solution. There are no salt particles at the bottom of the beaker. Now, if I were to add exactly 36 grams of sodium chloride to this 100 grams of water, okay? And I don't have a balance with me, so I can't measure it out accurately, but let's just say, okay, at some point I'm going to reach 36 grams of sodium chloride in the 100 grams of water. And then at some point I'm going to exceed it, and I probably have exceeded it at this point. So no matter how much I stir, or how much, even if I were to apply heat or pressure, that sodium chloride solute, salt, okay, table salt, will not dissolve, okay? If I had exactly 36 grams of sodium chloride per 100 grams of water, I'd have a saturated solution. But now what I have made is a supersaturated solution, okay? You can see that the sodium chloride is settling at the bottom of the beaker. No matter how much I stir it, okay? And this water is pretty, it's room temperature. It's not cold, it's not hot. But I've made a supersaturated solution, okay? So an unsaturated solution, a little bit of solute. A saturated solution, you have reached the saturation point, and for salt and water, it's 36 grams sodium chloride per 100 grams of water. And then a supersaturated solution, you have far more solute than solvent. And there you go, supersaturated. When we have a solution and the solute is dissolved in water, it's called an aqueous solution. Okay, so aqueous solutions are represented by the letters AQ in parentheses. Okay, so you have the solute, the formula for the solute, and then AQ next to it. So the solute in the demonstration that I did was sodium chloride, and it's an aqueous solution. It was dissolved in water, okay, from the Latin aqua for water. Okay, so the terms in section 12.1 and 12.3 are descriptive terms to help describe solutions. And you have many solutions in your home. I just mentioned about, in your refrigerator, if you have juices or if you have soda, sports drinks, okay? But a lot of your cleaning materials in your home are solutions, okay? Soap is a solution, okay? Whether it's hand soap or shampoo, soap for your hair, okay? Detergents are solutions. Bleach is a solution. It's actually an aqueous solution. Sodium hypochlorite. Okay, is a bleach solution. Okay, you have vinegar in your home. Okay, most homes you have vinegar. Okay, vinegar is a solution of acetic acid dissolved in water. And Lysol spray is a solution. Okay, it's an alcohol-based solution, mainly ethanol. With it's roughly 70 to 80% ethanol, depending upon the formulation, and you have chlorinated compounds and other compounds that are proprietary that are dissolved in there. But yes, that's a solution. Here, it's a liquid in there. Okay. In the next video, we're going to talk about ways to quantify solutions based on something that we call concentration. Okay.